Welcome everyone to today's broadcast. We'll be starting in another 5 minutes. Okay, so once again, thanks to everyone for joining us today's webinar here with Piet Knijnenburg, who will be presenting using data lifecycle management to improve operational performance. I see that people are still logging on right now, but since I'm going to just open up with a couple of slides on interfacing, as you guys join in, you can actually catch the good part of our session today, which is really Piet. So Piet, thanks a lot for joining us today. Much appreciated.
Welcome. You're welcome.
Piet has over 30 years of experience in application architecture and is a renowned author. You can go ahead and download his ebook for most vendors or on Amazon called Integration Architecture Beyond Technology. And he also is actively sharing his knowledge expertise on LinkedIn, lots of great articles. Feel free to, after this session, go ahead and follow him. Thanks again, Piet, much appreciated. So let's get it started first with just my portion, which is really a question of 2 slides. So for those of you who haven't attended any of these webinars or heard of interfacing in the past, our company has been around for over 25 years now, focused solely on process-based solutions, ranging back from the BPR years of business process reengineering through to the start and continuation of BPM and beyond, which is where we really are today. So not only are we a pioneer in the space, but continue to be recognized as a global leader. We're actually listed in 4 Gartner reports as of this year under business operating systems, enterprise business process analysis, operational intelligence, and even the latest being the digital twin. Beyond that, of course, we've been recognized in many other different categories for knowledge management, governance, risk, and compliance, amongst others, because we've really extended the platform well beyond just simply a mapping software or an automation tool. It's truly a technology for managing your enterprise. The tool in itself is broken into 2 major components. One, which is really focused on transformation, meaning the facilitation of your as is versus your to be, where you are today, where you want to be in 5 years. And the other being the digital business platform, which is really our automation platform, monitoring, forms design, rules engine, a system integration module, or for simplifying the integration amongst your different applications that you have in-house, and really a full entity designer as well. So the transformation platform, that actually really focuses on everything having to do with a central repository of your processes, your documents, your risks, your controls, your business rules, your master data, assets, roles, resource responsibilities, but much more just a repository. It's really made for the end user to really be used as a continuous improvement platform, whereby not only the analyst can use it for doing deep assessment, for lean assessment, analysis, improvement on that end, but also for the everyday user to log in and actually read directly on his phone and have a video of how to complete his tasks, really his end user standard operating procedure, and a platform for him to raise change requests, right? Improvement requests, collaborate, discuss around it, and then it's really actionable to going all the way through to improvement. So that's it for my part. I'm really going to be passing the baton off to Piet. So Piet, once again, thanks for joining us, and take it away.
Yeah, well, thanks everyone for joining the webinar, and thank you, Scott, for the introduction. Well, let me tell you a little bit about myself. Who am I? Well, I wasn't a corporate IT architect my whole life. In the 80s, I graduated as a paleontologist at Utrecht University, and as such, I was at the cradle of complexity science and of understanding the role that complexity science had in evolution and extinction. But in the end, I couldn't find a job as a paleontologist, and I ended up in software industry. After many years in many organizations and many integration projects, I gradually came to realize that exactly the same Darwinian principles that govern evolution and extinction in paleontology, that they apply everywhere, also in organizational ecosystems and in business process management and in software development. This has put these fields into a totally different light for me, and I'm going to share as much of it as I can in the next 45 minutes. So today we're going to talk about how you can use data lifecycle management to improve operational performance. Well, obviously, I'm not going to address the entire field of operational performance management because it's far too big. I'm an IT architect, so I'm going to address an aspect that I'm familiar with, and that's the IT support of operational processes. I'm going to show that IT support is not just your software systems and software applications that affect operational performance, but the cooperation or integration between your software systems and software applications is at least as important as the systems and applications themselves. And that's the area where data lifecycle management is going to make the difference. Well, IT support is a very broad topic. And to keep things clear, I'll limit myself to three facets. That's the direct support, the indirect support, and agility. What I call direct support is the support of your primary business processes. And in the early years of automation, this meant the replacement of manual registration of processes by automated registration of processes. This is not support of your primary business processes. This is the registration of your processes. And it's traditionally very much data oriented. But around the turn of the century, we gradually shifted from registration of processes to control of processes, and even the execution of processes. This you may call direct support. It's what I call direct support, and it requires a much more process-oriented approach. And I sometimes call this the invisible paradigm shift. We're not very aware of this change that has happened at the beginning of the century. It's important to understand that there is a world of difference between the original registration of data and what we're now doing, the control of processes. Indirect support are your secondary processes, like data warehousing, business intelligence, predictive analytics. The essential difference between the two is a failure in direct IT support may be felt immediately in your business processes, and a failure in indirect IT support will have no immediate consequences for your business process. And the third aspect is agility. You'll want your business processes to benefit from opportunities that arise from new IT technology. But also, if you want to change your business processes, you'll want your IT support to change at the same speed. So, data lifecycle management is a comprehensive approach to managing an organization's data and associated metadata from creation and initial storage to the time when it becomes obsolete and is destroyed. Data lifecycle management has always been a most important but often overlooked aspect of data architecture. But with the introduction of the GDPR, that's the European General Data Protection Regulation, and similar developments in the USA, we can no longer afford to overlook data lifecycle management. The aspect of data lifecycle management that is specifically important for our purposes is to know which business processes and which business events are responsible for the various phases in the life cycle of the data, and in what information systems it is registered or controlled. Also, we must realize that this needs to be done right down to the level of attributes. For example, if you're a car seller or a car producer, the license plate attribute of a car has an entirely different life cycle than the car itself. So let's look at this fictitious, very simple business process map. First of all, we must realize the fractalic nature of business processes. Each of these business processes can be decomposed into sub-processes, which can in turn be decomposed into tasks, etc., deeper and deeper. In the other direction, this process map, along with the process maps from other organizations, will make up the process map of a local economy, which in turn is part of a global economy. So you can zoom in and zoom out as far as you like. In this map, you can see that various processes are covered by various IT applications. This is not a one-to-one relationship. Several processes are covered by more than one, can be covered by more than one application, and one application can cover more than one process. You must realize that software too has a fractalic nature. Applications can be decomposed into software components that can be decomposed into programs, that can be decomposed into functions or procedures, or to use an old term, in subroutines. And in the other directions, applications can be composed into an applications network. Well, the question now is the business process as a whole, is it better supported by a collection of applications, or is it better off with an applications network? So what's the difference between a haphazard collection and a network of applications? Well, first of all, the difference is composition. Applications in an application network are carefully selected so they can easily fit into the network and leave no gaps and preferably no overlaps. Second, in an applications network, the applications are organized for each to be responsible for their part of the business process. Third, they're organized to communicate with other applications, to send signals and to respond to signals received from other applications. And fourth, cooperation requires coordination. If your communications and activities across a network are not coordinated, then these communications and activities will not be efficient or even will not be possible. Well, an applications network is a set of applications cooperating as a whole. We all have heard or read one-liners of this slide here before. Things work better when they work together on purpose, or a system is as good as the cooperation of its parts. Well, hopefully not only have we heard about these one-liners, hopefully we agree to them too. If the parts of a system don't cooperate, then the system can't function properly. The inference of this remark is that if applications in an applications network don't cooperate, the applications network can't function properly. Or in other words, integration of applications is at least as important as the applications itself. So let's not focus on the applications, let's focus on how to make them together. Let's focus on the fabric of an applications network. As I mentioned earlier, we evolved from manually registering data on paper to automated registering data on disk. Only later we discovered that some data was redundant and could be shared between applications. We then focused on getting data from one application to another, and in a predominantly batch-oriented systems of the previous century, we did this by exporting and importing data, and that worked reasonably well at that time. Well, with the evolution to more and more real-time business process support, we increasingly ran into various issues. Importing datasets, for example, means that you lose all context information, so your real-time systems cannot react to events occurring outside their direct sphere of control. Consistency issues were always a problem, but in real-time systems, error handling becomes more critical. Often, these export and import datasets are very specific and cannot be reused. Typically, they're being scheduled sometime in the night, thus creating an uneven load on your systems. If you look at performance monitors, a familiar pattern emerges. You have periods of inactivity spiked by moments of network and CPU overload. Often, entire tables or even entire databases are being extracted, while most of the content is identical to the previous extraction, and often the meaning of the data in the extraction is unclear or ambiguous outside the domain from where the data was extracted. And with the evolution to real-time processing, these legacy export-import solutions have become unsuitable in today's direct business process support. So these unsuitable integration solutions, they have a cost, they come with a cost. And it's not often clearly visible, but they can amount to quite a large total. The unnecessary load can increase CPU and network costs in metered environments. And often these legacy integration solutions lack sufficient maintenance tooling and monitoring tooling, which means it costs a lot of time to do this manually. Technically, these legacy integration solutions will work. Failures are often due to contingency, to convergence of circumstances, an unforeseen set of circumstances which together cause a failure. Often these causes are very difficult to find, very difficult to remedy, and even more difficult to prevent, and impossible to predict. Integration solutions that haven't been tailored to the needs of the business processes can potentially have a huge impact to these business processes. So maybe the initial cost of an unsuitable integration solution may be low, but the total cost of ownership, or the TCO, over the life cycle of an unsuitable integration solution can be very high indeed. So why are we using these unsuitable integration solutions? Well, the first reason, as already mentioned, they were already there. It's legacy and they were never replaced. The second reason, and it's probably very familiar, is the "we have always done it this way" syndrome. And the third reason is we're trying to get data from A to B, no matter how, just getting the data from A to B, ignoring the business process requirements. Well, choosing integration solution because of technology is another reason. For example, if an ERP system offers both SOAP XML web services and message queuing over RabbitMQ, and you're familiar with SOAP XML services but not with RabbitMQ, that might trigger you to choose the SOAP XML web services. That's not the right way to do it. Sometimes the wrong integration solution is chosen because the right solution is perceived as too difficult or too expensive or too time-consuming. Or even worse, these arguments are used as excuses because people are just plain unwilling to adopt change. This is short-term thinking. Even if you would need a little bit of extra investment, the total cost of ownership will be lower in the long run, and well worth the extra effort. The extra effort that you might need the first time will lessen the same or similar effort on subsequent times. In very rare cases, the right integration pattern cannot be implemented on one of the applications because of technical limitations or limitations of the off-the-shelf software. In most situations, there are ways to overcome these limitations, but if none are viable, you may have to resort to a second best solution. And last, we might have interfering requirements from other concerns, such as regulatory compliance or security. For example, the security officer may demand that an application that produces a payments file also encrypts and signs the file before sending it to a bank for processing. This constitutes a point-to-point solution and precludes using a decoupling point like a message broker, integration hub, or a service hub. Well, according to Wikipedia, application integration is a framework composed of a collection of technologies and services which form a middleware framework to enable integration of systems and applications across an enterprise. Well, as an integration architect, I'm not very happy with this definition, mainly because it focuses primarily on the underlying technology. Of course, it's much better than application integration is about sharing data between applications. But for me, a better definition would be application integration handles the support of your business processes across a heterogeneous landscape of applications. This definition immediately focuses on the main target, which is business process support, and the main challenge, which is how to do it across a heterogeneous landscape of applications. And to make things explicitly clear, I'm always tempted to add the clause independent of underlying technology to this definition, because really technology is rather irrelevant. The best way to work across a heterogeneous landscape of applications is to organize this collection of applications into an applications network in which the applications can cooperate as a whole. To achieve this, the fabric of the network will have to provide several capabilities. This communication, it must make sure that participants, the nodes in the network, are able to send information and receive information from each other over the network. This depends largely on technology, but sending and receiving information alone is not enough. It must find a way to let participants understand each other, even if the participants use different domain-specific languages. So another capability, harmonization, even understanding each other is not enough. The participants must also know how to interpret that information. If participants interpret information differently, we still are in trouble. We don't like the notion that every participant needs to know how each of the other participants interprets information. The network should enable all participants to use the same interpretation of the shared information. And we can do that with harmonization of the information. The third, what we need is coordination. The network must enable the information being transferred across the network, that it is coherent, and that participants send and receive their information reliably and timely. And last but not least, administration. The application network must enable you not only to register anything that happens on the network, it must also enable you to configure anything and monitor anything that happens on the network. Well, here we see a simplified representation of a small collection of heterogeneous applications. Each cylinder represents an IT system or application, and often each application uses its own vocabulary. I prefer to use the word vocabulary to avoid confusion with programming language, but it's the terminology we use within a domain, within a cylinder. It's also known as domain-specific language. SAP, for example, will give their entities and attributes certain names, while Microsoft Dynamics will give the same entities and attributes different names, and maybe even assign a slightly different meaning to each term. In the old days of point-to-point spaghetti integration, the data was exchanged directly between the cylinders. That meant that if SAP wanted to send data to, for example, a CRM system, it had to know which format, structure, and meaning the CRM system would expect. And if in turn the CRM system wanted to send data back to SAP, then the CRM system had to know which format, structure, and meaning SAP would expect. We created a system where every application needed to know everything about everyone else. Well, not a good idea. To avoid point-to-point integration, we are often advised to use a message broker, an integration hub, or a service bus as a middleman, as middleware. In other words, let the red arrows in this picture run over a middleware solution. Well, how wrong we were. Using a middleware only solves the technical tight coupling. It's nice, but it's not nearly enough. The real problem is functional tight coupling. What I just said, we created a system where every application needs to know everything about everyone else. That's functional tight coupling. And we don't solve that by just using middleware. So to overcome the problems that arise from functional tight coupling, we need to use an applications network represented here by the yellow disks. If you see this picture, you might be tempted to say that applications network is just a fancy term for integration layer. And well, you would be partly right. The difference is where the integration layer is a collection of artifacts related to integration. An applications network is a carefully designed structure to let connected applications cooperate as a whole. The integration layer only takes care of communication. Applications network also takes care of the other capabilities: composition, harmonization, coordination, and administration. And the whole in the phrase cooperate as a whole is defined by an enterprise model. It is also the key to harmonization. While the various applications use their specific domain models and domain languages and continue to do so, the applications network is based on the enterprise model. This enterprise model consists not only of a static enterprise data model, or also known as the canonical data model. At least as important is the dynamic enterprise process model, or just plain business process model. What I often see is that the enterprise model or canonical model is defined as a reconciliation of the underlying domain models. It's mostly the IT department that looks at what the underlying domain models have in common and declare that to be the enterprise model. Well, although it's better than nothing at all, it doesn't help us much. Far better it is to have a business architect outside the IT department creating a greenfield enterprise model, which is not based on existing domain models or existing solutions, but which is derived from the business process model itself. Once the business services that will land on the applications network have been defined, it is up to the IT department to define how they connect to the underlying applications. The downward pointing green arrows in this picture. Typically, this connector is a simple adapter using a mapping and a communication protocol to an existing or to be created endpoint in the underlying application. So let's get back for a moment to the distinction between primary and secondary business processes. Since the non-functional requirements or service level requirements are very different for secondary and primary business processes, it makes sense to make the same distinction in the integration solutions. Timeliness, accuracy, and reliability are generally very important in the primary business processes. Generally speaking, this is less so for secondary business processes. This allows us to change different integration patterns for integration of secondary processes. Typical for these secondary business processes is data gathering, copying the content of an application's data store to a location where they can be processed. These data integration services could also be called data gathering services, or even ETL, extract, transform, and load services, although for many this has an unintended connotation of classical data warehousing. Well, data gathering services are detached from the business processes, and that's the problem with using these services for primary processes. These services start, for example, often at a scheduled time or are triggered by the business intelligence solution. Hence, the gathered data do not have a business process context. If an item in the items extraction was exchanged, you don't know why it was exchanged. If an item was deleted, you can only tell when it's no longer present in the extraction where before it was. You only know that a new item was added if in the previous extraction it wasn't there. So most business intelligence and ETL suites, they offer standard solutions for these situations, but in primary business process support, the missing context may cause all kinds of problems. Another thing, you gather data as is, straight from the data set. This data is stored in the domain-specific language. While this is okay for business intelligence, where you generally want your data as raw as possible, it's not a good idea for primary operational business processes. This type of integration is also known as snapshot integration, because you take a snapshot of a data set, or you take a snapshot of the changes on a data set, a so-called delta file. It's okay for non-primary business processes, such as data warehousing, but it's dangerous to use for primary operational business processes. So here we see a business process coverage map, a little bit smaller than the previous one that I showed a few slides before. In fact, we see a business process flow with 7 steps in the main flow and 2 steps each in the 2 branches. The steps are represented in pale yellow. Well, it's not really visible here, but it is pale yellow. And the arrows denote the flow of information. We can also see that 5 line of business systems, or LOB systems, are used to support this process. The information flows that are denoted with the pale yellow arrows occur entirely within the coverage of an LOB system. We can expect that the LOB system will manage these information streams, and they may well be invisible outside the boundaries of the LOB system. The red arrows, however, are the information streams that enter or exit an LOB system. They cross an LOB system's boundary. An LOB system can manage its own entry point or exit point, but it cannot manage the entire information stream. This is the realm of integration architecture. One might say that integration is about getting data from one system to another. We already concluded that this is a very simplistic view on integration. Unfortunately, it's still a view that's shared by many. A much more precise statement would be that integration is about the business process information flow between software applications. Let's zoom into one of these information flows in the yellow circle. Here we see a small piece of an UML activity diagram in the business process model. For those not familiar with the activity diagrams, the horizontal strips are called swim lanes, and each swim lane encompasses the responsibility of one actor. This actor can be a person, a role, or a department, or in this case a system. And each arrow that goes from one swim lane to another constitutes an interface. If one of these swim lanes is a human, then we have a user interface. If both swim lanes are applications or IT sims, then we have a machine interface or an integration. For each interface, we need to establish just a few things. First of all, we need a business process context. Especially, we need to know the business events that trigger the information flow. Second, we need to know what information is associated with these events. And third, we need to know which integration pattern to follow. The first two activities should definitely be assigned to a business analyst outside the IT department. And the third activity is something the business analyst and the IT designer should agree upon. Once these three things are defined, the last two activities, defining the adapters and mappings at the endpoints, can be left to the IT designer. Well, when designing a business service, we require information in two categories. The first is the business process context. Most times, business events are obvious. An incoming sales order is such an obvious business event. And by the way, notice that in BPM, the underlying technology is irrelevant. We don't care if the sales order comes in via email or fax or telephone or via a website or as an uploaded file. But something like all active employees is not a business event. It does not have a business trigger. It's a snapshot extraction. A less obvious example of a business event is all HR changes that become active today. If you get promoted by the first of the next month, it's not the registration that constitutes a business event. It is the transition from this month to the next that triggers the promotion business event. Of all these events, we need to know the expected quantity and frequency and size, etc. Well, enough about triggers. We also need to know which business processes are involved. By their nature, business services often can be found at the intersection of two or more business processes. And of course, we're keen to know the responsibilities of the actors that are involved with respect to the process and with respect to the data. The maxim here is, if there's no business trigger, there's no business service, probably just a snapshot extraction. We also need to know which information is associated with the integration service. We need to know which entity, what elements, what attributes. It's well possible that ownership shifts during the life cycle of a data item. Suppose you're working in a manufacturing environment and that you are using parts to assemble your product. A new part probably starts its life in the product development process, but it may become the responsibility of the manufacturing process once production is underway. Well, at a certain moment, you may stop producing a certain product, but in the after-sales processes, you'll still have to maintain the parts for years to come. So it's a classic example of a life cycle change of a business object. Also be aware that the life cycle of data elements and attributes may differ from the life cycle of its owner. For example, a customer's personal data is owned by the customer, but we may delegate this ownership to a CRM solution. Well, the social security number, however, is created by the government, and the assessment whether a customer is a bronze, a silver, or gold customer is probably the sales department's responsibility. Well, we want to establish structure and representation. Note that it's perfectly okay to have more than one representation. For example, have a representation in JSON, in XML, and as a delimited standard flat file, as long as they share the structure and vocabulary. The structure should adhere to a standard model known as the canonical model. More on this later. An important and often overlooked aspect is to validate the data against the event. Are all the data elements that are recognized, are they related to the event? If not, you're probably violating a separation of concerns principle. So let's look at the canonical schema. To prevent a Babylonian confusion, we should standardize the information as much as possible. For example, the events and messages, order received, validate order request, and order approved will largely carry similar content. So we like to make sure that the shared content is structured identically. We can do this by using a canonical model. In the example I just gave, we created a canonical model of the order entity. We refer to that entity in the events and messages, order received, validate order request, and order approved. Any standardization effort can qualify as a canonical model, even if you create your own model for your own organization. In most cases, it would be better to adopt an existing standard model, and there are many out there. The best known are probably OAGIS from the Open Access Group, EDI and Swift. Well, these are original flat file based standards, but are just representation. SEPA, the European format for monetary transaction, HIPAA and HL7 for healthcare, but there are many, many more. Often you'll find that an existing model almost but not completely fits. In this situation, the first thing you must ask yourself is, am I reconciling existing solutions, or are my business processes so different from other enterprises? Many proposed standards have suffered from the designed by committee syndrome, so it's really up to you which standards you would like to adopt. If no standards seem to fit your requirements, you can create your own canonical model. But I would still recommend to use as much as possible of the vocabulary of one of the standards that comes closest. Well, just to allay some common misunderstanding, canonical models are not to be forced onto the domains. They live in the business process layer. And canonical models are not a reconciliation of the existing solutions, but a greenfield structuring of the data as required in a business service. Using a canonical model is loose coupling on the data level. Instead of having interdependency on the data level between two or more participants, you introduce the canonical model as a controller on the data level that the participants have to comply to. So we can distinguish different roles that the data source can have in the data lifecycle. An authoritative source is the information system that's responsible for the lifecycle or part of the lifecycle of a data element. Other terms like source system of record or the single source of truth are familiar and are closely related, but are not exactly the same. For example, for the registration of a part's lifecycle, this might be a part master solution from the manufacturing process. While some information is needed across various domains. For example, the administration of your parts inventory will need information for which the part master of manufacturing is the authoritative source. So you can either request the information from the part master each time you need it, or you can create a local copy of the part master in your parts inventory solution. In this relationship, the part master behaves like a master, and the parts inventory solution will behave like a slave, the local copy. The parts inventory solution may need to register some additional attributes with each part. That makes it the authoritative source for these attributes. And for these attributes, the parts inventory solution will then not behave like a slave, but it will behave like a master. Instead of registering its additional attributes in a local copy, the parts inventory solution could also choose to register in the parts master solution. In this case, the parts inventory solution is still the authoritative source for these attributes, but the part master becomes the delegate authoritative source for these attributes. And the CRM solution that is used to register your business partners is a good example of a local authoritative source. Business partners' lifecycle lies outside the span of control. Within the span of control lies the registration of the moment a business partner becomes relevant to your organization until the moment that this business partner becomes irrelevant. So it behaves both as a local copy of one or more external authoritative sources. It behaves as an authoritative source to local internal systems. So what kind of messages can we exchange over the applications network? Well, first of all, we do not exchange objects. Exchanging objects within a solution, within a program, is fine. There's no problem there. But exchanging objects across domain boundaries will introduce unwanted interdependencies and render the integration service brittle and prone to incidents. So we do not exchange objects, we exchange messages instead. This is an all-important difference. Messages that we do send and receive over the application network are commands like process order. There are events like order approved, submit messages like submit order, acknowledgements like order received, request messages like list active suppliers, and response messages like a list of suppliers that are active. Also, we don't exchange entities or business objects, but we exchange messages about business object, business events, which probably one or more business objects are involved. The same goes for records and composite records. Sending business objects or records or composite records reeks of data source extractions, reeks of snapshot integration, and it should generally be avoided for primary business processes. And a different kind of message is the error message. More on that later. So let's delve into the message types, the message nature. Commands. Well, don't send commands, or rather, your application should not send commands to other applications. This is an unwanted and probably hard-coded dependency between the applications. It's better to have a controller mechanism like an orchestration or a workflow engine to do the sending of commands to a next application. If you define a command, the suggested naming convention is imperative verb and noun, for example, perform credit check. And very important, it is quite normal to send commands to local copies, but be very careful when sending commands to authoritative systems, even via a controller. After all, authoritative systems are authoritative. They're not meant to be to obey commands. In many cases, you should send a request or submit a message instead of a command and leave the handling to the authoritative system. So how can we get a controller to send command? That's quite simple. We send events. Events are messages that an authoritative system publishes and to which clients can subscribe. The middleware that coordinates the publishers and subscribers is called the service bus. The advantage of this pattern is that the sender doesn't need to know who the receivers are and doesn't need to have authority over the receiver. And the coordination of the workflow is not hidden away inside the sender of the message, but it can be configurable from the outside. The biggest advantage, however, lies in error processing. There is no error processing. Since the sender doesn't know the receiver, it doesn't even know whether there is a receiver. It doesn't expect a return message. It doesn't need to. Since it's the authoritative source, it sends by definition the truth. And if a local receiver can't handle the truth, then that's a problem of the local receiver, not of the sender. So the receiver doesn't send back error messages. You should send events from authoritative sources. Events occur everywhere, but generally no one wants to know about events in local copies, only events from authoritative sources. The suggested naming convention is a noun plus past participle verb, for example, an order approved. Well, this slide shows the same process as slide 15, but now with a service bus and message flows superimposed. The various line of business systems receive commands, the white arrows, from the service bus, and after finishing the execution of a step, they send back an event, that's the blue arrow, and they send it back to the service bus. Upon receiving an event, the service bus either forwards the event to the next line of business system, or it forwards it to a workflow engine, represented here by the two top large cogwheels. Using an external workflow engine allows you to easily manage, monitor, and even alter the workflow of your business processes, but most service buses also provide tooling for monitoring, managing, and maintenance of information streams across the bus themselves. By using this approach, you've nicely separated execution and control, eliminated all interdependencies and most dependencies. It's important to understand that although a service bus architecture transporting XML or JSON messages over a message queuing protocol is best suited for this pattern, you could also implement this same pattern on a message broker or enterprise application integration hub, using whatever message format on various protocol. The technology doesn't really matter. Now, submit and request messages. They are the messages that a client of an authoritative data source sends to that authoritative data source. The message types are more or less equal, the difference being that a request implies an answer pertaining directly to the request, and a submit does not imply an answer. For example, you submit a tax declaration and hopefully you get some money back some weeks or months later. But you request the name and address belonging to a certain social security number, and you expect a reply. Submit and request messages may seem similar to command, and yes, the content may well be identical, but the handling is totally different. A command message originates from an authoritative source, so the receiver cannot question its content. The receiver has to process the content, and if there's any issue with the content, the receiver will have to resolve it. A submit or request message, on the other hand, originates from a client and is sent to an authoritative source. The authoritative source will try to validate and process the message, but if there's any issue, it will return an error. I said I would get back on error messages. So we can distinguish three categories: technical errors, such as connection failed; content errors, where the content of the message is not correct; and processing errors, where the underlying systems cannot process the message because in turn they run into some technical problem. It's important to communicate this distinction, since technical errors and processing errors cannot be resolved by the client, but content errors can. So the suggested naming convention is imperative verb plus noun, for example, registered client, or more explicit, registered client request. Response and acknowledge messages have a one-on-one relationship with a previous request or submit message. And that relationship must either be implicit, for example, it can be captured in the protocol, or explicit. When explicit, you must resolve it in the payload, the content of the message. The request or submit message must contain a unique key, either functional or technical, that the corresponding response or acknowledge message sends back. If you send 10 requests to a service, and then you receive 10 responses back, you really want to know which response belongs to which request. The difference between response and acknowledge messages is that an acknowledge message does not have any functional content. Depending on protocol, it may be empty, like an HTTP status 200, or an empty SOAP envelope. A sort of in-between message is a message that only contains a reference to a key by which the progress of the request can be followed. Very important is to understand that, contrary to what many believe, An ACK message does not provide 100% reliability. If you do not receive an ACK message, it does not necessarily mean that a request or submit message was not received. It can just as easily mean that a request or submit message was received and processed, but that there was a problem sending back the ACK message. By the way, the same goes for response messages. Changes of this happening are very slim, say 1 in 10,000 or 1 in 100,000. But if you have a scenario where 99.99% reliability is not good enough, you should consider strategies to mitigate this issue. The suggested naming convention is to use the name of the first part of the corresponding request or submit message, followed by response or result. For example, register client message would have a response message called register client response. Well, according to Wikipedia, business objects separate state from behavior because they are communicated across the tiers in a multi-tiered system, while the real work of the application is done in the business tier and does not move across the tiers. Basically, this is correct, but it does not state how they must be communicated across the tiers. As we have already demonstrated, for the primary processes, you do not export from one system to import into another. You will lose business process context, and we have seen what the consequences can be. Instead, you should incorporate business objects into your messages, into your messages. The invoice business object, for example, would be incorporated into messages like invoice received, approve invoice request, pay invoice, or list unpaid invoices response. Or records, they are not messages, they arose in a data source table. Records may be used for raw data gathering in data integration scenario and in CRUD microservices in the data layer. For those who are not familiar with the term CRUD, it stands for create, rate, update, and delete. In short, basic I/O operations on a data store. And even worse are composite records. These are the remnants of the past. In the early days, each time a client that needed data was that was available in another system, they would create a dedicated extraction tool that gathered the required data and lump it together as a set of composite records. Nowadays, we should really avoid the use of composite records, and certainly in the context of primary business services, but also in data gathering environment, they have lost their validity. There are some generic rules that apply to all messages that are to be exchanged through primary business services. Make sure no knowledge of a business service partner is needed. Certainly not technical knowledge, because the goal of an applications network is to achieve cooperation between applications independent of technology. But you should also avoid functional knowledge of your communication partners because it hampers agility. Better to leave that knowledge in the service bus orchestration or workflow engines. This means that clients of a service should either use their own proprietary formats and let the middleware perform the necessary transformation, or use the standardized messages or canonical messages that make up the lingua franca of the applications network. When defining your own canonical format, use existing standards wherever possible. Examples are the XML date-time format, the various ISO standards like country codes or currency codes, or other de facto standards like Microsoft's language code. And you should make elements unambiguous by qualification, by which I mean a disambiguation attribute added to the element. For example, an amount should have a currency attribute, and a dimensional element should have a unit of measurement attribute. And using enumerations may also be very helpful to standardize, but you should only use them for data elements that are rarely or never change, such as the 7 continents, or debit or credit in accounting, or the metal tiered levels, gold, silver, bronze. These are good examples to use for enumeration. And Use an enterprise data model for canonical messages to ensure that the same business objects are represented in the same consistent way in the various messages. And very important, make sure the message contains only information pertinent to its trigger or request. Again, an enterprise data model will be very helpful here. So, the basic scenarios overview shows a recap of the last slides. It shows how message nature is related to the role that a system plays in the lifecycle of your information and how you can derive a message exchange pattern from this relationship. This is the fourth column, and I see I'm already over time, so I'm not going to delve into this. The acronym MAP stands for Message Exchange Pattern. There are many recognized message exchange patterns, and the most important are listed here. That's FF, fire and forget, PS, publish and subscribe, RR, request response, SR, solicit response, and MFT is a managed file transfer. It can be interpreted as an accumulated form of fire and forget. It is the choice of the message exchange pattern that governs the technology that can be used for the implementation of an integration scenario. So to recap, business process governs the data that will be exchanged. The role that the various systems and applications have in the data lifecycle will govern the nature of the messages. The message nature and trigger governs the choice of a message exchange pattern, and the message exchange pattern will govern the choice of technology. So, just some simple rules of thumb. If your message contains an element or attribute called status, you're probably engaging in snapshot integration. Instead of defining a message with a value for status, you should define event messages that lead to the new values for status. Never use an operation code to steer the inner workings of a service. For example, do not define a process claim service with an element action where A means approve, C means cancel, and F means finalize. Normalize these services and create 3 services called approve claim, cancel claim, and finalize claim. If neither partner in a desired integration solution is authoritative with regards to the message content, you should question the validity of the solution. Being master or slave in an integration is a decisive factor in establishing the integration pattern. If you cannot answer unequivocally who is authoritative, then you should go back to the drawing board. For each integration solution, think of idempotency. What happens if I send the same message twice, and is it a problem if I send it twice? Avoid sequence dependency. Messages may follow different parts before reaching their destination. There is no guarantee that a message that was sent first will be received first. Especially in high reliability scenarios, one message can fail in the first attempt, then succeed in the subsequent attempt, and thus arrive out of sequence. And avoid stateful services. A lot has been written about the pros and cons of stateful and stateless services. I'm not going to repeat any of it. Bottom line is, don't use stateful services unless there is a very good reason to do so. Well, most of what you've heard, and I realize that I've been very late now, but most of what you've heard and seen in this webinar you can find back in this book, along with much more background and context. So it's moderately priced and available as a paperback on Amazon and on major ebook stores. So thank you for listening.
Thanks a lot, Piet. I know you ran a bit long, but I let you go because you had a lot of content to cover. So, and it was very interesting. Actually, a lot of it resonated to me, and I was actually quite surprised how much you really aligned against application network with our type of technologies. What I mean is everything you had to talk about regarding the triggers, the events, the process, roles and responsibilities, capturing the metadata, the entities, the attributes, linking them to the events, the processes, the systems. Really, that's our transformation platform. And then what you were saying to use for the integration and for the implementation being the workflow, we also have then that's really what we call our business services, which is our whole execution platform, which is a workflow. And, I really like too that how you said the choice is not an ESB or a workflow, because I've had that conversation many times in the past. They have two different purposes and they should both be used within the application network. So it was new to me to hear that terminology and very interesting and really resonated a lot. I know we're past, but maybe I could take one or two questions that I wrote down here. Actually, on that topic, someone wrote, what's the difference between application network versus BPMS?
I would say the application network is really the software that's binding all your applications and systems together, while BPMS is a business process engine. So yes, the two are related, but they're not identical.
Mm-hmm. I think maybe it depends at what level, right? The application network, as you talked about, whether the integration is done at multiple levels, but really the process flow is more of the end-to-end, which I think that's actually often a misconception where companies will say, I don't need a workflow tool because I have a workflow module within my system, let's say within SAP or within Salesforce, versus you'd want to have it one level up to communicate between SAP and
yes, that's
Salesforce.
very right.
I think it's the level, right? You talked a bit. I had one question here where they mentioned they saw SOAP, but there was nothing on REST, and recommendations in terms of which standard would you use is what they said in terms of if you had to make a corporate standard of communication.
Actually, I always say it's not really relevant, the technology that you use. But if you really ask me, then since REST is quite loosely and SOAP XML quite rigid, quite typed, I would prefer to use SOAP XML for business processes and REST services for the communication between the user interface and the business services.
Interesting. I would have answered. I feel like everyone's moved to REST now. That SOAP is a bit outdated. I agree with you that it's much more robust, not robust, structured.
Structured, yes.
Yeah, exactly. But it seems like for speed, agility, and the fact that most good applications now have a REST service layer, be my recommendation.
Yeah. And I think that agility is especially important between a user interface and the business services, but between the business services among themselves, they are much more stable. So you might benefit from the structure that SOAP XML offers.
All right, thanks again. I'll wrap it up because I know we're over 15 minutes now and I'm sure people want to log out. So thanks again, Piet, for everything. As I mentioned, it was very interesting. I really enjoyed it. I think I'm myself going to download the book and read it through, and because I see a lot of it relates to the work that we do. So I see good synergy there. So thanks again for your time today.
Thank you.
And everyone, thank you yourselves for sitting through today's session. Feel free to fill in the survey to give your feedback in terms of Piet's presentation or what we could do for future webinars. If you have any recommended future speakers, really this is an expert series of independent experts in their field, and we'd be happy to host them and have them on a future session. Thanks everyone for attending. Take care.